All right, let's get right into it. We're going to be talking about a topic that could be the secret villain behind your app's slow performance, and that is database indexing. You know the feeling, right? You click something, you search for something, and then you wait. And you wait. A lot of the time, the problem isn't some complex logic bug in the code. Nope. It's how the application is finding its data. It's a performance bug. And honestly, it's one of the most common issues you'll ever run into. So this slide really gets to the heart of what we're talking about today. On one side, you have the slow way, the full table scan. And on the other, the super fast way, the index seek. Our goal here is to show you exactly how to help turn those slow, painful scans into lightning fast seeks. To really get a handle on this, let's use a little analogy. I want you to picture your database table as this absolutely massive, sprawling library. So imagine your app needs to find just one piece of info, say one customer's record or a specific product. Well, without any organization, the database has to literally look through every single row, one by one, until it finds what it's looking for. That's the full table scan we just mentioned. And you can imagine, as that library of data gets bigger and bigger, this process becomes incredibly, painfully slow. So what's the fix? Well, it's pretty simple, actually. We give our library a magic catalog. Let's dig into how that actually works. Okay, so what is this catalog? Well, a database index is a special, highly organized lookup table. You know, it often uses a structure called a B tree, but the important part is that the database can use it to find the location of your data way faster. It's the exact same idea as using a library's card catalog to find a book's precise shelf location instead of just wandering up and down the aisles hoping you'll stumble upon it. But you know, it's not always that simple. Not all cataloging systems are created equal. Sometimes a simple search by the author's last name just isn't enough. For more complex searches, you're going to need some more advanced tools. For instance, let's say your users are constantly searching for orders from a specific customer and within a particular date range. A simple index on just the customer ID isn't going to cut it. But a composite index, one that's built on both of those columns, oh yeah, that can be an absolute game changer for that kind of query. And this is the ultimate trick for efficiency. Imagine the library's card catalog didn't just have the book's location, but also had a full summary printed right on the card. If that summary was all you needed, you wouldn't even have to walk to the shelf. That's exactly what a covering index does. It has all the data the query needs, so the database doesn't even touch the main table. It's just unbelievably fast. Okay, so now you might be thinking, great, I'll just index every single column. I'll make a catalog for everything. Whoa, hold on. There's a catch. Every single index you create is another book your librarian has to update every single time something changes. And this chart really shows that fundamental trade-off. See, indexes are amazing for applications that do a ton of reading, but they add extra work or overhead to every single write operation. Anytime you insert a new row or update an existing one, the database doesn't just change the data in the table. It has to go and update every single related index too. So the real key here is to find a good balance. Think about it. Over-cataloging a library where brand new books are arriving every single second would just create a huge traffic jam right at the librarian's desk. Well, the same thing happens with a database table that has tons of write activity. And this is where you, the tester, becomes so important. You're not just checking if a feature works, you're basically an efficiency inspector for the whole library. It's your job to make sure the catalog is actually useful, that it's up to date, and that it isn't accidentally slowing everything down. So here's a checklist to get you started. You can work with developers to look at something called a query's explain plan. Just think of it as the database's own blueprint for how it's going to find the data. And if you see the words full table scan in that plan, boom, that's your giant red flag. From there, you can time things, look for those complex queries, and even find old indexes that are just sitting around taking up space. I mean, look at this query on the screen. It seems totally harmless, right? But if you don't have an index on that department column, the database has to scan the entire employees table row by painful row. As a tester, that's something you should immediately flag as a potential performance disaster, especially as that table grows from hundreds of rows to millions. The good news is testing this stuff is pretty straightforward. This simple 4-step process gives you cold, hard data. You're no longer just saying, it feels slow. You're providing concrete proof. Hey, this query took 10 seconds before we added the index, and now it takes 50 milliseconds. By the way, inserts are now 5% slower. See? That's powerful, actionable feedback that developers love. All right, let's pull all this together into a handy cheat sheet. Basically, you want to focus on indexing columns that show up in where, join, or order by clauses, especially columns with high selectivity. That just means they have lots of unique values, like an email address. You generally want to avoid indexing columns with low selectivity, like a simple true-false column, or, as we said, tables that get written to all the time. But really, the most important thing, always check those execution plans and make sure the index you think should be used is actually being used. And this is really the big takeaway here. This kind of thinking elevates your testing from just asking, does it work, to asking the much more important question, does it work well when things get busy? And trust me, understanding the basics of database indexing is absolutely essential to that mission. So the next time you come across a slow screen or a feature that just feels sluggish and laggy, I want you to ask yourself this very question. Because the answer, and more importantly the solution, might just be hiding in the database, waiting for a good librarian like you to come and get it organized.